Every time I discuss climate change on this channel, I get rafts of people saying it's fake and rafts of other people saying it's going to lead to full-on human extinction. And these arguments often focus on one area, one graph, one phenomenon, one quote. How about if we step back and looked at the fundamental scientific case being made by each perspective to see how they hold up? Stop looking at trees, start looking at forests. Well, let's give it a go. My name is Mallen Baker. This is the Mallen Baker Show for Changemakers. Before we get started, let's just review what we know about how science works. Science is based on the premise that we can build our understanding of the world by close observation of what happens, developing a theory that is consistent with what we see, and then constantly checking that theory against new data and research. We never assume that there can be perfect proof of anything in science. It doesn't mean that the principal theories don't have such a strong weight of evidence behind them that it would take a massive upheaval to impact our confidence in it. Now, this mindset isn't really how the human race works left to its own devices. Although we might like to think that we form our opinions according to the evidence, observational studies have suggested that, to the contrary, we mostly form our opinions based on what we'd like to be true, or what our preferred peer group, whether social, professional or political, believes to be true. And you can see that must be the case because otherwise why would belief in climate change fall along party political lines as they do to such a significant extent in the US? If we were genuinely assessing the science, that's an extraordinary unlikely outcome. And sticking to the rigidity of the scientific method doesn't come naturally to human beings. We suffer cognitive dissonance in the face of evidence that contradicts what we already believe. We develop emotional attachments to certain theories and so on, which is why the scientific community builds in certain procedural standards, such as publishing your data so others can check your methodology and having articles peer reviewed before publication. Those are not perfect mechanisms because human beings are flawed, but over time they tend to mean that bad data gets corrected, flawed reasoning gets challenged, and our understanding of how the world works improves. The most robust science observes what happens and explains why. In addition to that, if your theory is solid, you should be able to predict what happens next. Prediction's harder, especially when you're describing complex systems. But ultimately, if your explanation of what's happening fails to predict what comes next, then either you've got the wrong explanation or there are additional factors whose influence you need to build into your models. Now, I'm going to explore the different positions here. There's always the danger that you end up putting forward what some would consider to be the weakest version of a theory. In other words, what's called a straw man argument. You misrepresent someone's case in a form that's easier to knock down. It's my intention to avoid that, but inevitably in a video of limited length, you can't cover every variation on a theme. So no doubt some people will argue their favourite argument or evidence has been missed out. In any case, it's not my expectation that this video, or indeed any other, is going to convert someone who's fully bunkered into their position. By and large, experience shows that facts and reasoned discussion isn't how people respond. But if you're not bunkered in, and you're curious, then you might find it useful. Okay, with all that said, let's start with the current majority position that supports the idea that human-caused climate change is a thing. What is the core scientific analysis that makes this stand up? For all the complex arguments about what is or isn't happening to this specific indicator or this species of polar bear or this wave of extreme weather events, ultimately it comes down to a few simple, easily measured parameters. We know that certain gases trap some of the sun's heat, particularly importantly carbon dioxide and methane. If they didn't, we'd be living on a very cold planet that almost certainly wouldn't support life at all. The principle of human-caused climate change is based on the following theory. 1. The Earth is warming up over recent years. 2. This is being caused because of human emissions of CO2 and methane, which is leading to more of the long-wave radiation from the sun that would have radiated back into space, instead being captured and sent back down towards the Earth. If this theory is correct, we'd expect to see certain things, some of which we would not see if there was an alternative explanation for the warming. First, obviously, we would see surface temperatures rising on aggregate across the globe. Weather is volatile, and throughout history we've seen periods where there have been localized weather anomalies, but that's different to overall global temperatures. So they would be going up. Second, because we believe that it's being caused by increases in greenhouse gases, we would expect to see the concentration of those gases increasing. Third, because we're positing that it's human activity causing the imbalance, we might see evidence that the additional carbon comes from fossil fuels. Fourth, because we're suggesting that increased quantities of greenhouse gases are reflecting the infrared radiation back to Earth, we would see less heat escaping into space over time. And because the greenhouse gases are in the lower atmosphere, we'd expect the upper atmosphere, the stratosphere, to show cooler temperatures because less radiated heat is reaching it. We would expect to see ocean temperatures rising, we'd expect to see ice melting and sea levels rising. That's it. If all of those factors show a positive, then you have evidence for your theory. Alternative theories have to provide explanations that better fit the facts. And as things stand today, all of those factors appear to be supported by the data. When we look at global temperatures from recent times, we see a clear warming trend. We haven't got direct temperature data to take this back through history for comparison purposes, but we do have what are called proxies. We can get evidence of historical temperatures from physical records, such as tree rings, for instance, as well as glaciers and boreholes, and a number of other things. Various people have carried out estimations of how historical temperatures have panned out, remember, for the overall world temperatures, not just individualised local ones, and they conform sufficiently to show that the period of warming we're now in is extraordinary in the context of history. Secondly, we do indeed know that the concentration of greenhouse gases is increasing. CO2 recently passed the level of 400 parts per million, which is higher than we believe it to have been throughout human history. In 1950, it was around 310 parts per million. Third, we know that the increases in CO2 are from fossil fuels, because fossil fuel CO2 is of a specific type. There are different what are called isotopes of carbon. The fuel that's associated with fossil fuels is what we see increasing in the atmosphere and is also to be found absorbed into the oceans and elsewhere. Fourth, satellite data over the last 40 years has confirmed that less heat is escaping into space. Fifth, similar data has also shown that while the lower atmosphere, the troposphere, is warming, the outer atmosphere, the stratosphere, is cooling. Exactly what we would have predicted from this theory. And as you're probably aware, we're seeing ice melting across the world, warmer ocean temperatures, both surface and deeper oceans, glaciers retreating and so on. All of those factors together add up to a significant body of supporting evidence for this theory. In order to predict what happens next, you get into various computer models where you're trying to identify and model all of the different factors that can affect the exact behaviour in global climate. Now that is an immensely complex project, but the logic behind explaining what's happening right now, as we've just seen, is pretty straightforward. So let's move to the competing theory, that human-caused climate change isn't happening at all. The basic principle for this argument is this, that climate change isn't happening at all, or if it is, it's within the normal parameters of historical variability, and there is a global conspiracy between climate scientists, the UN and a host of others to pull the wool over people's eyes. Some of the people in this area simply say, well yes, climate change is happening, but it's to do with solar activity. However, solar activity would not produce the results we've seen, with the troposphere warming and the stratosphere cooling. So rather than coming up with an explanation that fits the facts, the bulk of people in this space assault the reliability of the facts. Scientists are conspiring, various bodies are colluding. What initial credence would we give to that proposition? Really, it would have to be pretty low. I mean, that would have to be a massive global conspiracy, way bigger and tighter than anything we've seen before in human history. And what would be the motivation for such a conspiracy? What some say is that it's all about justifying research grants. People say, follow the money. Well, it doesn't make a huge amount of sense. There's no rationale why you get more research grants by doing fake research than you would for doing genuine research. On the contrary, the likelihood of being found out if you faked your research would be a general disincentive to do that, which would at least have to be countered by a powerful positive incentive. It's not as if certain individuals in the history of science haven't made the bad decision to fake something for their own purposes, but they're usually found out eventually, and for a whole community to decide to do something similar would be massively more prone to discovery. The bigger the group of people that know a secret, the more quickly it tends to become public knowledge. And, you know, we don't see a lot of climate scientists driving Ferraris, but by and large, the lifestyle of scientists seems pretty much in line with what we know to be the sort of funding that they get. For this global conspiracy to be successful, they would have to fake all of the key statistics for land temperatures, the increase in atmospheric CO2, the ocean temperatures, the cooling stratosphere, the ice melt, the various historical proxies, all of it. To believe in this conspiracy, you'd have to believe that climate scientists as a body were generally more corruptible than ordinary people, because our experience in every other walk of life is that there are good people and bad in every group, and the idea that you could have such a large field of people with no whistleblowers, just people following some slightly dubious incentives, it's not a theory that matches our understanding of human behaviour generally. And to do so with the connivance of so many official bodies, when so much of the raw data is public and can be checked, that all seems so unlikely that the theory has to start with very low credence. So if it's to be supported, there would have to be very good quality evidence to back it up. And there isn't. When it comes to the record of warming temperatures, there were attacks on the first Stark graph produced by Michael Mann, the so-called hockey stick graph. Subsequent teams reviewed the data, looked at different mixes of proxies and came up with broadly comparable results. So neither the findings of Michael Mann, nor importantly the suggestion that the warming in recent decades is unusual, seem to be refuted. This graph was produced by Tim Ball, which apparently shows that warming in the past was much greater than recent warming. That warming you see is the medieval warm period. But it seems to be cherry-picked data, using local temperature data rather than global data, because we know that the medieval warm period was a localised phenomenon. There were certain places where temperatures were warmer than they are today, but globally not at all. And that has been the usual pattern for extreme weather anomalies throughout history, so it shouldn't be a surprise. And the conclusion is also supported by the lack of evidence of ice melt from that period, which you would have gotten if these were global temperatures, not local ones. Let's take another example of how the skepticism works on a graph-by-graph basis. Let's take the example of satellite data for warming in the lower atmosphere. We had ground measurements for the warming using thermometers, and then we had satellite measurements. The challenge was that they didn't agree. Ground measurements showed a warming trend. Initially, the satellite measurements, although you can see correlating shapes, did not show the overall same warming trend. You'd expect these measures to agree. In any branch of science, when you get two different measures that should correlate but don't, then you seek to identify the cause of the difference, because either one set is wrong, or your belief that they ought to correlate is wrong. Either way, understanding the difference will help to inform your understanding for the future. Now, that sort of thing happens in science all the time, generally of interest only to the people wearing white coats in the immediate vicinity. If one of these two data sets is faulty, where would we give the highest credence of the error most likely to come in? The ground level temperature measures are using basic thermometer technology, pretty straightforward and robust, although you do have to make some alterations to ensure you're comparing like with like. The satellite technology is more complex, so you would naturally give a higher credence to the possibility there's some factor in those figures that you need to allow for. The satellites are not measuring heat. They're detecting microwave signals and making voltage measurements. Here's a picture of the algorithm of how those measures are turned into temperature measurements. Huge amounts more scope for error, as you can see. Now, in due course, the culprit was identified, and there are several factors that they hadn't corrected for, but principally including the decaying orbits of the satellites doing the measurements. The satellites were designed to fly over the same point at the same time every day to give comparable readings, but decaying orbits meant that the times actually changed. Corrections were built in, the datasets now largely show the expected correlation. In a neutral environment, that's just an everyday story of scientific folk improving their understanding and producing an improving quality of data for us to get to know what the world is. In case you haven't noticed, we're not in a neutral environment. And if you're a fervent believer that all the stats are faked, you're going to pounce on those sorts of changes. Here's a recent video with Tony Heller pouncing.
This graph was data from remote sensing systems and was pretty devastating for climate alarmists. Carl Mears is the head scientist at Remote Sensing Systems, and he immediately came under a huge amount of pressure to make this long hiatus of warming disappear. So this is what the data looked like on November 16, 2016. The red line is Remote Sensing Systems. And here's what the same data looked like almost 3 years later.
But again, if we step back and ask ourselves which is the simplest theory that explains the sequence of events, We have one relatively simple measure based on thermometers, one more complex one applying an algorithm to microwave radiation. They don't agree. One theory says we're trying to get the right measures, and we explore why there's no correlation, and we discover a flaw in the complex algorithm, which we can correct by factoring in the elements causing the problem. The alternative theory depends on what? That the global climate conspiracy had successfully faked the global temperature data, in spite of the fact that such data is collected by numerous agencies in ways that are quite easy to check. But it failed temporarily to fake the satellite data, but then after a couple of years it managed by means unknown to coerce a presumably previously independent team to toe the line. If your principle in understanding the world is that the simplest available explanation that fits the facts is probably the right one, you'd have to go with the first one of those, wouldn't you? But it underlines the point, and it shows how hard it is to carry out the scientific process, which involves openness, constant improvement and revision, when you've got people hovering over you looking for any opportunity to pounce and say, "Ha! Gotcha!" The long and short of it is that there's no scientific theory underpinning the skeptic's case against climate change. It's not to suggest there couldn't be an alternative science-based argument, but this isn't it. It presents no alternative explanation that fits the observed changes taking place in the world, just a barely credible denial that the measurements being taken are the correct measurements. And that's in spite of the changes that we actually see in the world that we would expect to see if those measurements were indeed correct, like ice melting, sea levels rising and so on. How can you maintain an argument that flies in the face of the data? By and large, with a number of rhetorical techniques. The use of conspiracy theories we've already talked about, but you can add to that amplifying a minority, focusing on the small number of contrarian experts and making their voices seem more important. So you get letters to the UN from a self-proclaimed group of 500 scientists. When you look at the membership of that group, almost none are climate scientists. Many are indeed professionals, but not scientists. And it's not a group that weighs equally against the body of scientific expertise supporting the established theory. And it's not a substitute for peer-reviewed scientific research anyway. And then numerous other devices, such as red herrings. Some people argue, for instance, CO2 isn't a pollutant, it's used as food by plants. Therefore we want more of it and not less. That's a red herring because nobody argues that it isn't used by plants. It's the quality of acting as a greenhouse gas that is relevant. They'll also group things together that they deem suspicious to make it seem that an unlikely conclusion is natural and obvious. You know, this figure seems to have been tampered with and this other figure was altered and then this one was misrepresented, so the inevitable conclusion is global conspiracy. Piling numerous pieces of weak evidence together does not turn it into strong evidence. Okay, enough of that. Now I want to turn my attention to the remaining group, the ones who say that they are champions of the science and extend that argument to suggest that the science indicates we're all going to be made extinct sometime soon. And indeed, the apocalyptic pronouncements of this group add fuel to the fire of the previous group, who can point to their excesses with justification and hence bolster the apparent credibility of their own claims. So the principal theory for this group is identical to the standard science one. They agree with the measurements of basic temperature rises and that these are attributable to greenhouse gases. What we have is apparently a question of degree. Some in this group, such as Guy McPherson, have argued that the most extreme case, that humanity will be wiped out within the next decade, although even in this group that is an outlier opinion. Others say that what's inevitable is societal breakdown as a result of major interruptions to things like food supply and direct damage caused by extreme weather events such as heat waves. They argue there are numerous tipping points that will inevitably result in runaway climate change. They argue the IPCC is too conservative a body and the truth is much worse than they are suggesting. They're represented by certain outlier scientists and much more widely by some of the key spokespeople for groups like Extinction Rebellion. Now this is a hard one to evaluate because basically it takes the facts of what we see in the world around us, but then through choice takes some of the most pessimistic predictions of some of the absolute outliers and convinces themselves that these are not only likely but inevitable. Sometimes this gets justified by referencing what's described as the precautionary principle. This describes a working principle that was adopted some decades ago at a time when new products that had novel chemicals were often believed to be potentially causing harm, but the line was always that there was no proof that it caused harm, and on the principle that it should be able to be used until such proof was established. Not unreasonably, it was pointed out there might be a better way, that it would be better if it wasn't allowed to be used until it was proven safe, and that's the essence of a precautionary principle. Unfortunately, although it sounds good in principle, taken to its logical conclusion, the precautionary principle simply counsels against taking any action that involves risk. And of course, that's not as helpful as it might be. If you decide the level of risk to be tolerated is a very low threshold, then you simply end up with paralysis. And you have to factor in that not doing anything may carry an equally large risk. So in practice, you find it gets used as a weapon to support an assault upon anything that a particular group doesn't like, while conveniently being forgotten in areas that it does. Extinction Rebellion's plan for zero emissions by 2025, for instance, would carry huge risks and negative impacts in all sorts of ways, but they never think that they should apply the precautionary principle to it. More to the point, they then use the precautionary principle in a way it wasn't really intended, to assume that the outlier worst case scenarios should be treated as likely and policy developed accordingly. We've already said that predictions are hard. In this area it's made harder because there are certain potential tipping points where something could be triggered that then adds to the problem. For instance, methane being caught up in the Arctic permafrost, which might then be released by the melting of that permafrost and then adding to the amount of greenhouse gases. Science is aware of many of these potential challenges and has evaluated some of the likely impacts, but ultimately you're dealing with unknowables. And certain people have been quick to talk about catastrophic impacts and runaway climate change. Because even if it seems a small chance, the precautionary principle means we should treat it as definitely true. If you applied that version of the precautionary principle to every other area of human society, you'd quickly bump against the impracticality. You would assume that every outbreak of a new disease was for sure going to be a virulent major pandemic, likely to wipe out a significant proportion of the human race. And you'd certainly shut down any research into AI because you'd have to assume it would definitely turn into an apocalyptic death machine, and so on. You get the idea. Applied indiscriminately, you end up paralysing and taking disproportionate actions with huge unintended consequences in the name of jumping at shadows. The key clue that this group is not based on the science is that when all's said and done, they use some of the same tactics as the ultra-skeptics. And they don't do a conspiracy theory with relation to the science, but they do use a catch-all, which is that the IPCC is too conservative and therefore important science that signifies imminent mortal danger is simply missed out. It may not intend to be a conspiracy theory, but it effectively is, since you're assuming that people are knowingly leaving stuff out in spite of its world-shaking consequences. But it more vigorously pursues certain other tactics, amplifying minority voices and using quotes from scientists whose opinion that they approve of to demonstrate scientific credence in the absence of peer-reviewed scientific research. Also, taking a list of very low probability risks, listing them all together and presenting it as meaning certain system collapse. As we identified before, bundling together a group of weak arguments does not equal a strong one. And the focus on societal collapse, as first referenced in a discussion article by Jem Bendel on so-called deep adaptation, which wasn't high enough quality to get through peer review, is put forward as an inevitable conclusion that would mean massive numbers of deaths, but nowhere is there specific rationale or evidence for what would trigger such a collapse. And how that would even work in a modern global society. It's simply proposed that some of these risks will kick in, suddenly people will be starving because we became incapable of feeding them, and instead of coping with and triumphing over adversity, which has happened often in history when difficult times have struck, we would unaccountably fold like a house of cards in a Category 5 hurricane. Of course, there are risks in a modern world with complex and just-in-time supply chains. Even so, there's nothing scientific about that proposition. It's not to say you couldn't make the case, but nobody has, not as far as I've seen. It's simply taken as read that if you add this bad thing to this other bad thing, that equals social collapse. And we do know enough about human beings and human society to be very suspicious of this tendency to fear the end of days. We've seen many groups and movements that have convinced themselves that the apocalypse is nigh. In the 4th century, Hilary of Poitiers predicted the world would end in 365 AD. In 1843, William Miller predicted the end to his thousands of followers. The 1910 arrival of Halley's Comet was another occasion. There were many, many others. Of course, the fact people thought it multiple times and it wasn't true doesn't in itself mean it can't be true. I mean, if you get out of bed every single day and tell yourself, today will be the day you will die, sooner or later, even if it's much later, yeah, you'll be right. However, the historical and psychological evidence that this is a thing we do should give us pause. It should make us examine the evidence behind our beliefs with keen criticality, because we know that we have this tendency to tell ourselves these powerful, compelling stories. When the mainstream scientists are saying this is not the end of days, albeit that it is a serious concern and we need to take action, then you should think carefully before concluding that they must be wrong, which may lead you to making serious life choices that you might regret. It's weird, but when you point to the scientists saying that this isn't supported by the evidence, more often than not, people from this group will respond with anger, whereas you'd expect them perhaps to be relieved and happy. But as I said early on, following the evidence is not what we happily do as a species. In those previous instances, when the apocalyptic groups gathered together in expectations of the fulfillment of their prophecy and it didn't happen, they didn't walk away, realise that they'd been wrong and celebrating the fact. They often doubled down and came up with reasons why the original premise was true, but something had intervened, and they were often gutted that it had done. If someone's being rational in the face of the science and believes that it's apocalyptically bad, and then they find that even though it's bad, it's not that bad, you should see some degree of happiness, for this has turned out to be the case. When you see the opposite, something else is going on. It's not science. So that's my roundup of the 3 flavours of climate change that we have out there. I know I'll be hearing from the passionate folks that are firmly rooted in the 2 extreme camps. I'd be extremely interested to hear from anyone with other things to say, and anyone who's been feeling confused and anxious, and what might help them provide some light in that situation.